Hi, this is Group 29. We'll be presenting on construction and demolition waste management planning. The intent of this credit is to reduce construction and demolition waste disposed of in landfills and incineration facilities by recovering, reusing, and recycling materials. Construction waste is a significant portion of the waste produced in the world. Keeping materials out of landfills prevents ground and water pollution, promotes recycling, and keeps materials in active use longer. Both planning and implementation are critical to reducing construction waste. Waste management services vary widely between locations, so planning for construction waste management before construction allows time to determine the most effective way to divert waste. To achieve the materials and resources prerequisite to, a project team must first develop and implement a construction and demolition waste management plan. A construction and demolition waste management plan establishes waste diversion goals by identifying at least 5 material sources targeted for waste diversion. These materials should be from both structural and non-structural elements of the building and should be reported with their estimated percentages of the total project waste. It is also important to specify whether materials will be separated or commingled in the planned diversion strategies for the project. During the construction process, all waste diversion should be tracked in order to create a final waste diversion report at the end of the project. The final report must detail all major waste streams generated on site and include accurate waste disposal and diversion rates. Alternative daily cover, or ADC, is a material cover other than earthen material that is used to cover waste at the end of an operating day to prevent the spread of material waste and does not constitute as an alternative form of waste diversion. Land clearing debris is waste generated from the removal of vegetation or site preparation for land improvement. As such, ADC and land clearing debris do not qualify as diverted material under LEED specifications. The first step to building a construction waste management plan is to identify the waste diversion goals. This includes 5 construction or demolition material streams for diversion from landfill. Common materials that may be simple to divert include drywall, wood, scrap metals, brick, and concrete. Next, determine the best collection and diversion methods for the materials. There are various waste collection and sorting opportunities, and the best method is different for every project. Step 3 consists of drafting a construction waste management plan. This plan should include the targeted materials and the collection and diversion methods that will be used. This plan provides a basis to determine if the project is eligible for credit and if it would be wise to pursue. Even if the project team does not decide to pursue credit, they must still develop a plan and continue with Step 5. The final step is to create a final report on the total construction and demolition waste produced by the project and the total waste diverted. There are many different strategies to effective construction waste management. On-site separation or source separation is a common method used and is the best option if multiple bins are conveniently located and the general contractor and subcontractors enforce careful separation. It is best to target materials that easily separate and have established recycling markets such as steel, wood, and concrete. Commingled collection or single-stream recycling is a method better for sites with limited storage area. Recyclable materials are mixed in one container but sorted and processed at an off-site recycling facility, which separates them from the waste going to a landfill. Another effective strategy is to donate surplus or architectural salvage as long as the material can be verified and tracked.
To earn credits under Materials and Resources Credit 5, project teams must prioritize efforts to recycle and/or salvage non-hazardous construction and demolition materials. When tracking diverted waste, calculations can be made based either on the weight or volume of material, as long as the reported values are consistent throughout the project. Excavated soil, land clearing debris, and materials designated for alternative daily cover cannot be included as diverted materials. While wood waste that is diverted for biofuel conversion can be included in calculations, other waste to energy efforts cannot be used to earn this credit. If a project cannot achieve the credit requirements by using reuse and recycling methods, Alternative waste to energy methods may be considered as waste diversion if they conform to standards set by the European Commission Waste Framework Directive and the Waste Incineration Directive. Additionally, waste to energy facilities must meet applicable European Committee for Standardization standards to earn this credit through waste to energy initiatives. There are multiple ways in which a project team can opt to earn credits from Materials and Resources Credit 5. The first approach to earning this credit is through diversion of material waste created on the construction site. By diverting 50% of all material waste created on a job site from 3 different material waste streams, a project can earn 1 credit. Additionally, a team can earn 2 credits in this category by diverting 75% of waste created from 4 different material waste streams. The second approach to earning credits in this category is by reducing the total quantity of waste material created. By generating no more than 2.5 pounds of construction waste per square foot of the building's floor area, a project team can earn 2 credits in this category. To earn this credit in the Materials and Resources category, the first step is to implement a Construction Waste Management Plan, or CWM plan. After the CWM plan is created, the project team can calculate the waste diversion rate, which is defined as the total waste diverted from landfill divided by the total waste produced by the project multiplied by a factor of 100. Once the project diversion rate is calculated, a final waste report for the project can be created and must include the following information: the total construction and demolition waste produced by the project, the types of waste material and quantity of each material, and the total waste diverted and the diversion rate reported as a percentage. Project teams should consider design strategies that will greatly reduce the amount of waste that is generated on site. Strategies such as fabrication, modular construction, and designs that use industry standard sizes greatly reduces the amount of waste that needs to be managed and diverted from landfills and incinerators. To calculate the total waste reduction, the waste per area is equal to the total construction and demolition waste generated divided by the project gross floor area times 100. An effective practice is tracking waste throughout the entire project. The project team will determine the best strategy for tracking waste throughout the project, which will then feed into the construction and demolition waste management calculator provided by the USGBC or an equivalent tracking tool. Web-based tools provide contractors with an easy step-by-step process for electronically tracking and submitting waste management and recycling plans. Electronic tracking can save them time and money by identifying recyclable materials, locating the nearest recycling facilities, following recycling progress, gathering comprehensive statistics, and creating reports regarding waste generation and recycling for the project, clients, company, government, as well as for green rating systems. Some tools provide lead credit templates so that data can be transferred directly to lead report formats. Option 1 of this credit requires that at least 3 material streams must be diverted from landfill. A material stream is defined as the flow of materials coming from a job site into markets for building materials. A stream can be either a specific material category that is diverted in a specific way or a mixture of several material categories that is diverted in a specific way. Examples of material streams include deconstructed materials sent to reuse markets, commingled waste sent to mixed waste recycling facilities, source separation where each material is sent to a specific facility, manufacturers or suppliers take back of materials, or reuse of deconstructed materials on site. A material stream should also make up at least 5% by weight or volume of total diverted materials. Option 2 of this credit is achieved through source reduction, which eliminates waste produced by a project. This can be done in 3 different ways. Prefabrication is a great alternative for many wall assemblies because they are manufactured off-site in a more efficient manner, thereby producing less waste. Modular designs are constructed in controlled environments and are a safer option for workers. Designing for material lengths reduces the amount of offcuts and scrap produced. It reduces waste and does not add to cost if incorporated early on in the project. Materials reused on site are not considered waste for the purpose of calculating option 2 only. The release of the LEED V4 system included the addition of the construction and demolition waste management planning prerequisite, which had not previously existed in LEED 2009. The revised LEED system added the ability to gain compliance through overall waste reduction and developed a method to earn credit when a project cannot meet basic credit requirements. The LEED V4 system also increased the requirements on waste diversion by requiring that 3 material streams be identified for 50% diversion to earn points. Additionally, alternative daily cover no longer counts as diversion as it had in the previous version of LEED.